Okay, so at negative 70 millivolts, the neuron is at rest. So this is called resting potential, and that means there's more sodium ions than there are sodium ions on the outside of the neuron, or the axon, than potassium on the inside of the axon. And so, which makes the outside positive and the inside negative. And so once the stimulus reaches its threshold or passes its threshold of negative 50 to negative 55 millivolts, the sodium or the sodium voltage gated channels open, which causes the sodium to rush into the membrane, making the outside positive, making the outside negative and the inside positive. And so after that, it keeps rushing in until it hits a voltage of positive 30 millivolts, which causes the potassium gated channels to open, which causes the sodium or the potassium to rush out of the membrane, making it, balance again. But then to balance the number of sodium ions to potassium ions, the sodium pump releases 3 sodium ions out of the membrane and 2 potassium ions into the membrane, and that's called hyperpolarization. So when the sodium pump opens, that's called depolarization. When the potassium pumps open, that's called repolarization. And then when the sodium pumps open, that's called hyperpolarization. And meanwhile, the action potential is traveling down the neuron or down the axon into the axon terminals, and then at the axon terminals, or once it reaches the axon terminals, the calcium voltage gated channels open, so the action potential causes the calcium voltage gated channels to open, which causes calcium to rush into the bulb, which makes the vesicles release the neurotransmitter acetylcholine, and then the acetylcholine goes into the synaptic cleft and then binds to the chemically gated channels, which release the sodium. And then the sodium goes down goes through the sarcolemma, and then through the T tubules, and then through the sarcoplasmic reticulum. And there's a graded potential because it's proportional. So if the more sodium is released, the more calcium is released. And so once calcium is released, it travels and then it binds to the troponin. And then once that binds to the troponin, that makes the tropomyosin displace, which opens the binding site of the actin and the myosin heads. And so the myosin heads need ATP to contract a muscle, and so the ATP binds to the myosin heads, but then the ATP breaks down into ADP and phosphate. And then so once that binds together, the myosin head pulls on the actin, which makes the myosin head pull on the actin, and then that's called a power stroke, and that's the muscle contraction. Done.